Hello everyone, and welcome back to the channel. Today, we're diving headfirst into the world of monumental machinery. What you're looking at right here isn't just a piece of metal, it's a 10-ton beast of a workpiece, and we're about to put it through a large diameter turning operation. This is where precision engineering meets raw, unadulterated power. The sheer scale of this task is mind-boggling. Every single rotation, every millimeter of material removed has to be perfectly calculated. There's absolutely no room for error when you're redealing with a component of this size and weight. Let's talk about the machine that makes this all possible. This isn't your average workshop lathe. This is a heavy-duty turning center, a true titan of the industry, specifically designed to handle jobs of this magnitude. The bed of the lathe itself is a testament to structural engineering, built to support immense weight without the slightest bit of deflection. Chuck, the part that grips the workpiece, has to have an incredible amount of clamping force to securely hold 10 tons of steel while it spins. Just imagine the physics at play here. Forces are enormous, and ensuring everything stays stable and secure is the #1 priority before we even think about making the first cut. Setting up a job like this is an art form in itself. It's a meticulous process that can take hours, sometimes even days. First, the workpiece has to be carefully lifted and positioned onto the machine using heavy-duty overhead cranes. The operators, who are masters of their craft, guide it into place with incredible precision. Once it's on the machine, the really tricky part begins: dialing it in. This means ensuring the workpiece is perfectly centered and aligned with the axis of rotation. We're talking about accuracies measured in fractions of a millimeter. Even a tiny misalignment on a workpiece this large would be amplified dramatically, leading to vibrations, poor surface finish, and potentially a catastrophic failure. They use specialized gauges and sensors to get it just right, making tiny adjustments until it's perfectly true. Now let's get to the main event, the cutting process. The tool you see here, the cutting insert, might look small compared to the workpiece, but it's made from some of the hardest materials known to man. Like carbide coated with specialized ceramics, this tiny tip will be responsible for peeling away layers of solid steel as the massive workpiece begins to rotate. Slowly at first, and then building up to the optimal cutting speed. The operator carefully brings the tool into contact with the surface. The moment of first contact is always a tense one. You can hear the change in tone as the insert bites into the metal, and a continuous ribbon of steel, or what we call a chip, begins to form and peel away. The sight of these chips is something to behold. They aren't small shavings. They're long, hot, and razor-sharp spirals of metal that glow red from the intense heat generated by the friction of the cut. Managing these chips is a critical part of the operation. If they build up around the tool or the workpiece, they can cause a lot of problems. From damaging the surface finish to becoming a serious safety hazard, you'll often see a high-pressure coolant system blasting a stream of fluid directly at the cutting point. This does 3 things. It cools the tool and the workpiece. It lubricates the cutting action, and it helps to break the chips and wash them away into a collection bin. The amount of heat we're dealing with is immense. Without proper cooling, the cutting tool would overheat and fail in a matter of seconds. Precision is the name of the game. Throughout the entire process, the operator is constantly monitoring everything. They're listening to the sound of the cut, watching the shape of the chip, and checking the dimensions with incredible accuracy. Modern machines like this one are equipped with advanced computer numerical control, or CNC systems. The operator programs the desired final dimensions into the computer, and the machine executes the tool paths with unparalleled precision. But it's not just a matter of hitting go and walking away. The operator's experience is irreplaceable. They know how to adjust the cutting speeds, the feed rates, and the depth of cut in real time, based on how the material is behaving. They might take a roughing pass first, to remove the bulk of the material quickly, followed by 1 or more finishing passes to achieve the final, precise dimension and a smooth surface finish. Let's take a closer look at the scale we're working with. This workpiece has a diameter of several meters, or the look of the surface, and we'll pause the operation to replace the insert. This ensures that the quality of the cut remains consistent from start to finish. It's a delicate dance between pushing the machine to its limits for efficiency and maintaining the highest standards of quality and safety. Look at that surface finish. After the finishing pass, the steel can be as smooth as glass. It's incredible to think that this mirror-like surface was created by a process of controlled material removal. Every feature on this part, whether it's a specific diameter, a groove, or a tapered face, has a purpose. These large components are often critical parts for major industries, like a shaft for a massive ship's propeller, a component for a wind turbine, or a part for a giant piece of mining equipment. The tolerances they have to meet are incredibly tight. A few thousandths of an inch can be the difference between a part that works perfectly and a very, very expensive piece of scrap metal. The entire environment in a heavy machine shop is built around safety and efficiency. The floors are reinforced to handle the weight, the air is filtered to remove any fumes or particles, and every operator is highly trained in safe operating procedures. When you're moving 10 tons of steel, you don't take any chances. From the crane operators to the machinists, everyone works together like a well-oiled machine. It's a symphony of skill, power, and technology. The level of coordination required is truly impressive. And there you have it. The process is nearing completion. Hours of meticulous work, this massive 10-ton piece of raw steel has been transformed into a precision-engineered component, ready to play its part in some of the world's most demanding applications. It's a powerful reminder of what's possible with modern manufacturing. It's not just about cutting metal. It's about shaping the world around us, one giant, perfectly turned component at a time. The skill and dedication that go into a job like this are truly inspiring. It's a testament to human ingenuity and our ability to tame incredible forces to build the future. Thank you so much for joining us on this journey into the world of heavy machining. I hope you found it as fascinating as I do. If you enjoyed this video and want to see more incredible manufacturing processes, make sure to hit that like button, subscribe to the channel, and ring the notification bell so you never miss an update. Let us know in the comments what other massive machines you'd like to see in action.